over the past few billion years. In the course of its evolution, Earth has endured numerous catastrophes, such as impacts from extraterrestrial asteroids, assaults from gamma-ray bursts in deep space, as well as its own ice ages and supervolcanic eruptions. It can be said that the survival of life on Earth is truly a miracle. And today, we will look back at the evolutionary history of Earth to witness how Earth formed and then evolved to support countless life forms. Hello everyone, this is the Space Science Station. Welcome to this episode. To understand the evolution of Earth, we must turn back time to 4.6 billion years ago. Approximately 4.6 billion years ago, our solar system began to form from a giant molecular cloud. This cloud continuously collapsed under gravity, forming a vortex. As more and more matter gathered, the temperature and pressure at the cloud's core also rose. When certain conditions were met, hydrogen atoms began to undergo thermonuclear fusion at the center, and thus our protosun was born. After the sun's birth, the remaining material in the outer regions continued to orbit the sun. Over time, this material also aggregated under the influence of gravity. Gases formed the gas giants, while heavy elements formed Mars, Earth, and other rocky planets. In its initial stages, our Earth was very active. Its interior constantly vented gases like hydrogen sulfide, methane, and carbon dioxide. These gases formed the first primitive atmosphere. At the same time, Earth was continuously bombarded by asteroids from space. But soon, Earth experienced an even more violent impact. About 4.5 billion years ago, a Mars-sized planet headed straight for Earth. Then, in this epic collision, this planet was almost completely destroyed, ejecting a vast amount of material into Earth's orbit. Gravity then bound these fragments together, forming our moon. At this time, Earth had a satellite, but its surface was still a high-temperature molten state, with no oceans. All water existed as gas. As time passed, the temperature began to drop, and the surface gradually cooled and solidified. Water condensed into small droplets and fell in the form of rain. Thus, the oceans were formed. Earth became a water world. Water is a crucial ingredient for the creation of life. Around 3.8 billion years ago, life emerged at Earth's hydrothermal vents. These earliest life forms were the most primitive single-celled organisms Over the next billion years, these organisms changed the course of the world. Through continuous evolution, prokaryotic life appeared. Around 2.5 billion years ago, the Great Oxidation Event occurred on Earth. Cyanobacteria evolved to become our planet's first photosynthesizers. The Earth began to fill with oxygen. However, as time went on, oxygen levels on Earth increased, while carbon dioxide levels decreased, causing the Earth to become colder and colder. Thus, 2.4 billion years ago, it experienced its first ice age. The entire planet was almost completely frozen. Around 2.35 billion years ago, the glaciers began to recede. Continents continuously drifted and reassembled. 1.8 billion years ago, a supercontinent formed, known as the Columbia supercontinent. Meanwhile, life in the oceans also became more complex. After a long period of evolution, they evolved from primitive prokaryotes into eukaryotes. Then, around 540 million years ago, an explosion of new life occurred. This event is known as the Cambrian explosion. During this period, animals evolved hard body parts, such as arthropods, brachiopods, and chordates. Among the most famous were the trilobites. Around 440 million years ago, a star 6,000 light-years away went supernova. The resulting gamma-ray burst struck Earth, destroying about half of the Earth's ozone layer. This led to drastic changes in Earth's climate. Approximately 80% of all species went extinct. Earth experienced its first mass extinction. This event is known as the Ordovician Silurian extinction event. In the following ages, Earth began to recover after a long period of restoration. 350 million years ago, the first trees emerged from the Earth's soil. At the same time, the first marine animals began to move onto land. $250 million years ago, Earth experienced an unprecedented series of continuous volcanic eruptions. Large amounts of toxic gases and dust enveloped the entire planet. Organisms were unable to adapt to the drastic climate change, leading to the extinction of 90% of all life. This mass extinction event also paved the way for the evolution of later animals. $230 million years ago, the first dinosaurs appeared. They ruled the Earth for nearly 160 million years. If you could place yourself in this era, you would witness the largest land animals of all time, as well as the fiercest predators. But good times don't last forever. As time went on, a terrible disaster was quietly approaching. About 65 million years ago, an asteroid with a diameter of 10 kilometers collided with our Earth. The force of the impact exceeded 100 trillion tons of TNT equivalent. During the violent impact, a massive amount of dust and debris was thrown tens of thousands of meters into the sky. This dust then spread with the atmospheric currents, covering the entire globe. It blocked the sunlight, causing devastating climate change on Earth. Ultimately, the dinosaurs that had ruled the Earth for 160 million years were driven to extinction. Only small mammals survived. It was this extinction that, for later humans, paved the way for their emergence. About 6 million years ago, a new species appeared. They are the earliest known hominids, the ancient apes. At this time, human ancestors could still walk on all fours. It wasn't until 4 million years ago that these early hominids began to transition from quadrupedalism to bipedalism. After millions more years of evolution, Homo habilis and Homo sapiens appeared. They also learned to use tools and how to control fire. About 10,000 years ago, the only remaining humans on Earth were late Homo sapiens. They no longer lived a nomadic life, but settled down, entering the agricultural age. The earliest forms of writing appeared, and human civilization was born. About 250 years ago, humanity entered the Industrial Revolution, pioneering an era of replacing manual labor with machines. Our social systems and culture underwent tremendous changes. Simultaneously, the population continued to grow. By the last century, human technology had reached new heights. We entered the space age. We were able to leave Earth and travel to the distant moon. And our unmanned probes have even reached the depths of the solar system. To this day, human technology continues to develop. Who knows what the future holds for the destiny of humanity? But that is another story. Black holes are the most mysterious and terrifying objects in the universe. They can tear apart any matter that passes within their event horizon. Even light, the fastest known thing, cannot escape once it enters its range. So for such a terrifying object, if you were to fall into a black hole, what phenomena would occur? Hello everyone, this is the Space Science Station. Welcome to this episode. Black holes are different from other celestial bodies in the universe because they are the product of the death of massive stars. When a massive star reaches the end of its life, it ends in a supernova explosion, leaving behind a core. If the mass of this core is more than 3.2 times the mass of the Sun, then gravity will overwhelm everything else, causing the core to collapse into a terrifying black hole. At the center of a black hole is an infinitely dense and hot singularity. All matter is compressed into an infinitely small point. And the more matter in the black hole's singularity, the stronger its gravity. So strong that not even light can escape. This is why we can never see them directly, but we can find traces of them through other means. For example, the accretion disks produced when they devour other celestial bodies, or by observing celestial bodies orbiting an invisible source of gravity, we can detect the presence of a black hole. So if you were to fall into such a black hole, what would happen? We all know that every black hole has an event horizon. Once you cross it, there is no turning back. Unless your speed can exceed the speed of light, you will not be able to escape. As you gradually approach the black hole, you would first see the surrounding space-time severely distorted. You would also see a large number of photons moving along the black hole's event horizon. However, you wouldn't have much time to admire this view, because the black hole's powerful gravity will pull you towards its center faster and faster. As you approach the edge of the event horizon, first, your feet will experience a much stronger gravitational pull than your head. Then, the heat and energy generated around the black hole will burn you up, and your body will gradually be stretched by tidal forces, like spaghetti. Before reaching the event horizon, you would be completely torn apart into particles. Then, as particles, you would orbit the black hole and eventually fall into the black hole singularity. However, the above applies to a stellar mass black hole. If it were a supermassive black hole at the center of a galaxy, it would be completely different, because the tidal forces of a supermassive black hole are much gentler. In this case, as you cross the event horizon, your body would not be harmed, because gravity would pull on your feet and head with almost the same force. You would slowly fall into the black hole singularity. An observer outside the event horizon would see a different scene. As you approach the black hole, they would see your speed slow down. This is because of the time dilation effect around the black hole. To an outside observer, your passage of time would seem incredibly slow. You would also appear darker and redder. This is because the gravity of the black hole stretches the wavelength of light, making it appear red. Once you fall past the event horizon, no one would be able to observe you anymore. you would be plunged into endless darkness until you reach the singularity. Some scientists speculate that if you were to fall into such a supermassive black hole, you might not die, but instead be ejected from the other side. This exit is called a white hole. A so-called white hole is a type of celestial object predicted by scientists. Based on Einstein's general theory of relativity, it is thought to be a special cosmic body that only emits and does not absorb matter, the exact opposite of a black hole. Simply put, when a black hole swallows matter, the matter passes through a white hole and is released into another space. And this passage is what we usually call a wormhole, also known as an Einstein-Rosen bridge. However, the above is only a hypothesis. After all, white holes are still just a theoretical model. Currently, astronomers have not yet found any evidence of the existence of white holes in the universe. Thank you for watching The Space Lens, exploring the mysteries of the universe. If you enjoyed this video, don't forget to like and subscribe to join us on the next journey through space.